Okay, folks, let's get off to a good start on Lesson 19, the basics of hypothesis testing. So up front, the gist of what we're doing is we're making a claim. How about someone claims that 5% of USG college students are taking E-Core classes? Let's just make believe that. So that's a claim. And what you need to be able to do is test that claim and to see if it's valid. So we need to go through a process of setting it up. We have to get some information. So we're going to take a sample of USG students, and then we're going to go through some type of process. It's going to use some calculations. There's going to be some number crunching going on, and then we're going to come up with a conclusion. And we don't want our conclusion just to be, based upon our feelings. We want it to be scientific, if you would. And in order to do that, we need to know what we're doing in this business of hypothesis testing. So it's very important that we do this work correctly. If it was a competitor or a marketing research and you found out that a company was lying, well, it could be false advertising, or it could be the name of their company could be hurt. Think about how often that happens in our country. Okay, you could really hurt that company's future. You may be related to the owner of the company, so there are really some ramifications of this particular type work. Of course, what you want to do is make this an unbiased presentation of the data. And at the core of hypothesis testing, what's operating behind the scenes are the ideas of the central limit theorem. And you're going to see that come up in our example in just a second. All right, let's take a look at an example. So in our quick example, we're saying 5% of the students, they're enrolled in E-Core. Okay, that's our claim, right? Okay. Now, you've heard that somewhere. Let's just say you heard it in advertising. But in your experience, you actually believe there are more, but you don't really know. Okay, so you're going to make a statement. I believe there's more, okay, than this claim, and you're going to go make a sample. Of course, when we think about that, all of the things involved in a sample, a random sample, the value of n, and so forth, are important. Now, let's just say you have a sample, and down at the bottom are the values, the percentages, if you would. Okay. Of course, this really should be p hat, right? But we'll just say this value is representing, okay, let's just say that just represents the claim, okay? Now, let's just say this represents 5%, okay? That represents 5%. And you end up with the value in your sample that shows you it's like at 4%. Well, now you're going to go through a lot of trouble with this test. Are you going to say, are you going to conclude that yes, it's greater? Well, obviously you're not, okay? Now, what if your sample was way over here in like the tail? See the tail region of this distribution, okay? You're believing, based upon what you know already, that is pretty highly unlikely that if we assume this was the mean and then my sample was over here, what's the probability of that being true? That is a very good question. So remember, when you do your sample, you basically have two choices. A, you know what? Our value is close to the claim. Maybe they're right. Okay, maybe they're right. So your conclusion is you just keep the claim. I think they're right about saying it's 5%. The other possibility is this B. So you're looking over here, you say, looks like the value there of 5 could be wrong. And you reject it. Your conclusion is you say, sure enough, according to our study, okay, the percentage of people is greater. okay? The percentage is greater. And you probably want to include some kind of number to quantify that statement. This is the gist of hypothesis testing. Okay, this lesson is really about setting up the test. So what we're going to do is we're going to formally write our null hypothesis, the claim. What is the claim? The claim is that this average is, I'm just going to say, it's the grade in the class. The grade in the class, the average is 82. Okay, if you listen to my report to the class, you know if it's right or wrong. That's my claim. Now, someone in the class says, you know what, we have very bright students in here, and I think that the average is more, okay? So they're going to say greater than 82. All right, so this top one's called the null. This is called the alternate or the research hypothesis. You've seen this before somewhere, I am sure. Now, if your challenge to the null hypothesis is greater, you're looking for values over here. That is called the right-tailed test. If it's less than, you're going to be over here. And if it's a two-tailed test, what that means is you're making the claim, well, I don't think that the average of the class is an 82, but I'm not sure. I'm just going to say it's not equal to 82. And you have to take into account both. Okay? That's the gist of how this claim is related to your distribution of your sample. Okay, I know you've heard me say this before. I'm a simple man, so let's just get right into the question. All right, so this is some of the statements below refer to the null hypothesis, some to the alternate hypothesis. State the null hypothesis, 8 sub O, the null hypothesis. State the alternate hypothesis, 8 sub 1, in terms of the appropriate parameter. Like I said, it could be the mean of a population or it could be a proportion of the population. All right, folks, let's do number 1. The mean number of years Americans work before retiring is 34. All right, it sounds like a simple claim. So the hypothesis, the null hypothesis is that you're saying the years, the average years of people before they retire is 34 years. That's a long time to be working, right? Now, that is the null hypothesis. We have to come up with the alternative hypothesis. Well, there's no statement there, so we're just going to say it's not 34. This is all you have to do with question 1, okay? Now, there are some nuances to this, and let me give you an example. All right, look at number 5. Fewer than 5% of adults ride the bus to work. Well, that is really an alternate hypothesis, okay? You could say that 5% of the adults ride the bus to work. So mu, actually that would not be right? That would be, it's a proportion. So, y'all forgive me here for messing up here, that's okay. All right, so you're going to say P hat, or P is equal to 5%, okay? Then your alternate hypothesis is P is what? According to the sentence here, what is it? Is less than 5, okay? Now, blunt moment of truth, I really think the way the sentences are worded in this particular exercise could throw you off a little bit. Look for my key and maybe that can help you out. I will be doing the best job I can at making this plain. I may have to adjust a couple test questions and so forth, and that is fine. That is my job. All right, the other part of that lesson had to do with type 1 and type 2 errors in completing sentences. So let me just see if I can do the best explanation possible. Okay, let's just make believe that this is coming pretty easily to you. Type 1 would be rejecting the null hypothesis when you should not. So you mistakenly concluded differently. And type 2, not rejecting 8 sub O when you should have. In other words, you really should have said that there was a difference between the claim and your challenge is correct, but you just kept things the way they are. So that's the difference in a type 1 and a type 2. Now, say it another way. Well, let's just do this problem first. Let's look at number 1. The mean number of years American work before retiring is 34. Okay, so a type 1 error would be the mean is not 34 when it is. Okay, so maybe I should write that out here again. Remember, we did this before. The null hypothesis is that the mean is 34. And 8 sub 1 was the mean is not 34. Okay? A type 1 error is saying the mean is not when it is. Now, what would a type 2 error look like if I made that mistake in problem number 1? I would be saying I conclude that it's 34 when it's not. It actually is higher, or it's lower, or it's different. Okay, now you're probably saying, Mr. Staples, I'm one of those people that didn't pick up on that too easily. Let me just kind of hit it another way. A type 1 error is like a false alarm. So you changed it when you didn't need to change it. Okay. I'm sorry. I'm just thinking about a person having a baby. Okay. A false alarm. Okay. No, we're just going to continue in the same state. Okay, that we were in. All right. Type 2 error. Type 2 error is a missed detection. A missed detection. So you should have detected something, but you didn't. You concluded that it was 34 when it's not. All right, let that settle for a second. All right, how about number 2? At most, 60% of Americans vote in elections. Well, a false alarm would be saying more than 60% when that's not true. Or you conclude that this amount is less than 60% when it actually is greater. Now you're going to have to take a little time to run through these and to try to make sure you get it, because it is a little confusing, and I'm just warning you. It's not the whole thing about this unit, but you certainly want to get off to a good start. Okay, so I'm calling this, here's some additional information. If you conclude a claim is not true when it is, you could have a lawsuit, you could be fined, or there could be unnecessary changes to a product. If you conclude a claim is true when it actually is not, products could be made the same. You could have some problems, or no new law or action could be taken. Think about seatbelts and that sort of thing. This is a very low down explanation. Type 1, think about I won a football game, but right at the end, coaches made a call, and we thought we won, but it looked like it was, looked like we were in trouble. But no, it was a false alarm because they figured out they were wrong. Or type 2, how about type 2 diabetes? Okay, I have diabetes, and I went to the doctor, and he missed detecting it. He did not detect it, and he should have. That would be a type 2 error. I do wish you well in finishing the task. Just go through this a couple times here, and I think you'll get it. And don't forget your quiz. I hope you do well on it the first time, if not the second time. All right, best wishes as we begin Unit 4. I hope you'll find 19 or 20 a little bit easier.